Welcome back, everyone. This is lesson 6. It's on the surface area of a sphere. The parts of a sphere, we'll look at the parts before we go into any formulas. The center of a sphere, as you would imagine, is the same as the center of a circle. So inside the sphere, this is the center here, right in the middle. The radius can be measured anywhere from the center to the edge of the sphere. That's an example of the radius. The diameter would be the complete length from one side of the sphere through the center to the other side here. So that there would be the diameter. As you'd imagine, the diameter is 2 times the radius. The circumference can be measured around the center of the sphere. So if you know this length here, you'll know the circumference of the sphere, which is actually the same as the great circle. So this circle, when you cut the sphere in half, this circle that is formed is called the great circle. The chord is any point from one part of the sphere joining to another part, anywhere you like. From here across to there, these are all chords of a sphere. And of course, they're all different lengths. Okay, the surface area of a sphere was discovered by the Greek mathematician Archimedes a long time ago. Okay, so we're not doing any new maths here. We've known about this stuff more than 2,000 years. Importantly, he found the total surface area of a sphere was equal to the curved surface area of a sphere with the same height and width. We'll look at what that means now. So you can imagine we have a sphere inside a cylinder. So the edges of the sphere touch the edge of the cylinder, here, and also at the top and the bottom. So if that was a ball you put inside a tin and you tried to shake the tin, then the ball would not move because it's tightly inside the cylinder. Okay, so what we said before is that the surface area of the sphere equals the curved area of the top but what we'll do now is derive the surface area of the sphere. Imagine that you have a sphere inside a cylinder. Now the cylinder touches the sphere at the top and bottom and the sides. So if that was a ball inside a cylinder and you tried to shake the cylinder, the ball would not move. It's tightly inside the cylinder. So firstly, the curved area of the cylinder is 2 pi RH. This is some grade 8 maths. So this curved area of the cylinder is equal to 2 pi RH. The height of the cylinder is 2r. So we have one radius here, we have one radius here, which is equal to the height of the cylinder. So what we do is we replace the height with 2r. So in our formula, we'll have 2 pi r times 2r. That 2r is replacing the h in this formula here. And we simplify, and we'll end up with 4 pi r squared. So it's actually equal to 4 circles. with radius r, 4 pi r squared. So it's not too hard to remember that formula. Now we need to think about the surface area of a hemisphere. A hemisphere is when you cut your sphere in half, okay, and then the top bit is cut off. So this gives us a hemisphere here. If we cut, the curved area of the sphere is half the total area of the sphere. Okay, so the curved area of the sphere will be 4 pi r squared from the last page, divided by 2, we give 2 pi r squared. So that's this area here, the outside area of the sphere, of the hemisphere. If the hemisphere is a solid, then we must include the flat circular base, which is here. That part is a circle with radius r. Okay, so the total surface area of the hemisphere is the curved area plus the flat circular base. So the curved area is 2 pi r squared, which is here, plus the flat base, which is pi r squared. So the total area of a hemisphere, of a solid hemisphere, is 3 pi r squared. Okay, but if it was hollow, if you had a cup which is shaped like a hemisphere, then you won't have any top area. You'll only have the outside area here. So if it's a hollow hemisphere, then your formula would be just 2 pi r squared. Okay, here's our first example. We have a sphere. Now take note here that this is the diameter, not the radius, because it has a solid line through the center. So the first thing to do is write your formula, which you should do every time, which is 4 pi r squared. What is the radius? We need to divide our radius by 2 here. So we'll end up with 3.85 feet. Then we put that number into our formula. So 4 pi times 3.85 squared will give us 186.27 square feet. Don't forget your unit, and the unit is square feet because we're dealing with area. In this question, we want to find the exact surface area of the solid hemisphere now. Now note the keywords solid and also hemisphere. So the first thing to do, determine the radius if you're not given it. The radius will be 6 divided by 2, which gives us 3. The curved surface of this hemisphere is 2 pi r squared. Write a h there. So this curved area is 2 pi r squared. So the curved surface is 2 pi times 3 squared. We'll get 18 pi square centimeters. At this point in time, I like to keep this as pi, in terms of pi. Don't change them to decimal just yet. The circular base is pi r squared. That's this area here. So pi times 3 squared will give 9 pi square centimeters. And the total surface area is the sum of those two numbers, which is 27 pi square centimeters. I may want the answer in decimal, but notice what I wrote here, exact surface area. So if you keep it in terms of pi, this means exact. It's an exact answer. If you round it off using 3.14, it's not exact anymore. Okay, so just take a note of how I want the answer. I may want it 2 decimal places, then you can round this off using your calculator. Example 3, we want to find the radius of a sphere whose surface area is 324 pi square centimeters. So we've got a sphere, we have a known surface area. So the first thing to do, write your formula, which is 4 pi r squared. Substitute the given surface area and leave this in exact form for now. So that is 324 pi. So that goes in the place of the surface area here. Now we'll rearrange our equation to isolate r. So divide both sides by 4 pi. So 4 pi, 4 pi, and then that's what we have here. At this point, the pi will cancel. And we'll end up with 324 on 4, which is 81. And remember, we have an r squared here, and this is why we have a square root here. When you square root both sides, this square root will cancel this square. So r is root 81. So your radius here will be 9 centimeters. And that will give you the surface area, 324 pi. Another question you'll see, especially in your workbook, you'll be given the radii of two spheres in the ratio 2 to 5. What is the ratio of their surface areas? So we write the ratio in this form. Surface area of sphere with 2 units to surface area of a sphere with 4 units. And our formula is 4 pi r squared, remember, for the surface area. So 4 pi times 2 squared, because the radius is 2, and 4 pi 5 squared. At this point, the pi will cancel. So I would not convert this to a decimal. If you make it a decimal, you may not be able to cancel this easily, okay? So leave it in terms of pi, this question. So we'll end up with the 4 cancelling as well, and we'll have 4 on 25. So the radii of the two spheres is 2 to 5. The radii of the areas is 4 to 25. Okay, good luck with the questions, and I'll hope to see you working soon.